once we get the fourth root, we did say earlier that because it's a fourth root, you still want it to have greater than or equal to 0. So basically we want 2 minus x to be greater than or equal to 0, which is the same thing that we did earlier for part B. So in this case, you're going to get x less than or equal to 2 for your domain. Or you can use interval notation and go negative infinity to 2, and it would be an equal there, and there you go. For this guy, we have a couple of problems. One is that in order for this to be defined, because the inside function is the square root of x thing, this guy has the condition that x is greater than or equal to 0. So that does matter. Part A, we have that. It has to be greater than or equal to 0, but now we need 2 minus root x to also be greater than or equal to 0, because that's inside an additional square root. So then if we add the square root to the other side, and then we square it, we get that x has to be less than or equal to 4. So now we know that it has to be greater than or equal to 0, but also less than or equal to 4. And again, this little symbol looks kind of funky. It's supposed to be a less than or equal to. Looks a little weird there. So there we go, x less than or equal to 4. So then we get 0 to 4 for our domain on part B. And then we're going to go, as promised, to C and D, which I think are the ones that cause people most problems because, well, they're weird. They're a function inside of itself. So let me erase this. And if you're wondering, I just wanted to make a quick note. I don't tend to make pre-cal videos because I can never stay within a 30-minute window because the pre-cal sections are so packed with information. So I apologize if this video might go a little bit over 30 minutes. I think we were already like at 25 or so before the video camera went crazy. And now I just have a couple more examples to do. So hopefully you'll forgive me, but I just want you to have the information while I'm gone. So, okay, so for part C, we want to go f of f. So we're going to put f into itself. So f of, so now my inside function is the same as the outside function. So I'm still going to do it the same way. The outside function is the square root. So now all I have is the square root of the square root of x. And as we said before, a square root and a square root, as long as it's all encompassed there, is the same thing as the fourth root of x. Alrighty? So that one wasn't so bad. But then you need to put the domain, which of course we said it's the same as the square root of x. So you can either do it with that kind of notation, or you can say it's going to go from 0 to positive infinity. There is your domain. And then we need to do d, which is g of g. G of x, like gg. So g of x means you're going to take g, the outside function is square root of 2 minus, and then instead of x, you're going to put another square root of 2 minus x. And now the only issue here is, again, you don't want to try to simplify it into a fourth root because it's not all underneath that second square root. But this is going to pose a little bit more of a dilemma again with the domain. Oops. Why did that happen? My mallow. With the domain. So we already know that for the inside function, the 2 minus x part, that x has to be less than or equal to 2. And now we need to make sure that 2 minus the square root of 2 minus x is greater than or equal to 0. So we're going to go 2 greater than or equal to the square root of 2 minus x. And when we square both sides, we're going to get 4 is greater than or equal to 2 minus x. And then we're going to subtract those here. And 4 minus 2 is 2, greater than or equal to negative x. And then when you divide by a negative, you flip the sign. So we have negative 2. And instead of a greater than or equal to, you're going to have a less than or equal to, and then x. So x can be greater than or equal to -2, but it has to be less than or equal to +2. So you end up being between -2 and 2. So you want to be greater than -2, but you want to be less than +2. And you get that for your domain of part D, G of G, otherwise known as GG. All right, so anywho, that takes care of that guy. I will, and then we get to go to our next example, which is actually a little bit easier, in my opinion, in the sense that it doesn't have A, B, C, D, E, F, G. But here we go. Oops, I don't even know why I saved that. I meant to go to my color palette. Okay, so you have three functions, f of g of h. And this is, like I said before, it's so much nicer to have that, come on little guy, come over here, to have that other notation. So I'm going to do that. I'm going to go f of something, right? And then inside of that, we're going to have a g of something. And inside of the g, we're going to have h of x. All right? And this is nice because now what we can do is we can go, okay, f of, and then g of, and instead of putting h of x, we replace h of x with what it is, which is x plus 3. And then we go to f of, and then you want to go to the g function. You want g of x plus 3. So the g function is x to the 10th power. So it's x to the 10th power. But you're going to put x plus 3 instead of, and now you have x plus 3 to the 10th power. And then finally, the f function is x over x plus 1. So we're going to put x over x plus 1. But what goes in these brackets or in these parentheses? This does, x plus 3 to the 10th power. There you go, x plus 3 to the 10th power. Now, if you want, you can just simplify everything at the very end because I don't think you need all of these parentheses anymore. But you do need the x plus 3 to the 10th power on top and the x plus 3 to the 10th power on the bottom plus 1. All right, and this one, it didn't actually say to find the domain or anything, so we're good to go. See, I told you that was a little bit easier than the last ones. So now we're going to go to our next one, which I also think is easier, or a little different than what we've been doing. And this is asking us to kind of work backwards a little bit because they're giving us a function that looks like something that could have been composed to get it to this point. So they want us to find what f and g would have to be in order for it to be equal f of g of x. So they want capital F to equal f of g of x, like that. So what you have to look for is, when you look at this function, what appears to be on the inside? If you had to pick an inside, what would be on the inside? And I'm hoping that you're going to look and you're going to see x plus 9 is on the inside. So that means that g of x is basically x plus 9. And if g of x is x plus 9, if you were to take that x plus 9, then what is the outside function? The outside function is then the square root, the fourth root, sorry, of something. The fourth root of g of x. Or in other words, the fourth root of x plus 9. So the outside function would be the fourth root of x. So that means that my f function, my little f function, is the fourth root of x and my inside function is g of x equals x plus 9. And that's basically what it wants to find functions f and g such that f of g of x would equal the original function. So g of x equals x plus 9 and 4th root of x for f. So that takes care of that guy. And we have one last one to do. Sure you're all excited about that because you're probably tired of listening to me, but a little word problem for you. And that doesn't help for us to have that off over there. Woohoo, there we go. All right, a ship is traveling at 20 miles per hour parallel to a straight shoreline. So here you have your shoreline, and the ship is over here, and it's traveling parallel to the shoreline, okay? The ship, this ship right here, is 5 miles from the shore. So this is right here, 5 miles from the shore. It passes a lighthouse at noon, okay? So that's just stuff to know, right? Now, something that I don't know if you can see from the diagram if you look in your book, these little things right here are indicating that even though this looks like a triangle, it is a triangle, but it's kind of skewed from the perspective that they're giving it to you. But this little guy says right angle, and that little guy says right angle. So that means that as their parallel lines are like this, they're right angles. So this little guy's a right angle. It just looks very skewed. So my point in telling you that is they're asking us in part A, express the distance S. So here's my distance S, and if this is a right angle, this is the hypotenuse. It says express the distance S between the lighthouse and the ship, lighthouse and ship, as a function of D, and here's D, marked over here, D, the distance the ship has traveled since noon. So this one's pretty easy. For D, because they told us that it's traveling 20 miles per hour, that's easy, it's 20t. All right? But they want us to find S. That's the little question right there. So it says express the distance S between the lighthouse and the ship as a function of D. And that means that they want this equation to say S equals something with D in it. So just to remind you, if you have y equals x squared, this is a function where you're expressing y as a function of x. If I put c equals PR, this is expressing f as a function of p and r. So they want me to come up with something that says S equals something with D in it. That's what I have to find out. That is why it's important for you to remember what I just said earlier about the whole Pythagorean theorem and that right angle. Because this is a leg, and that's a leg, and that's the hypotenuse. And we know that the relationship between leg, and hypotenuse is 5 squared plus D squared equals S squared. Now they don't want S squared, they want S. So we just do this little guy, and now my S is equal to the square root of 25 plus D squared. So that is part A. Express the distance between the lighthouse and the ship as a function of D, done. S equals F of D, done, all right? For part B, that was part A. So for part B, I think we've already done it, accidentally, but we did it. Part B, express D as a function of T, the time elapsed since noon, that is, find G, so that D equals G of T. Well, yeah, we already found D, it's 20T. So here we're going to say D equals 20T, because we already said it before. And then in part C, find F of G, what does this function represent? So again, this is the distance S as a function of the distance D. Okay? Now part B, this is a function of the distance D in terms of time. That's important for this last little question right here. So what's F of G? That one's going to be easy. We're going to replace D with our function G, which is 20t. See if I can squeeze that in there. And there you go. S equals the square root of 25 plus 20t in parentheses squared. That's my function. I'm not even going to simplify it because I don't need to. So what does it represent is what it's asking. The function f of g of x, or sorry, f of g of t, which is right, g of t, so if you replace, if you want f of g, right, so before you had f of d, right, you had s equals f of d, and now you replace that d with g of t, now you have a function s in terms of time. And that's what the last part of the answer is. So the distance d, so this would be the distance d, which is the distance of the ship, as a function of time. And that is how the cookie crumbles. Alrighty, so that's the last example. So now I am going to say au revoir. I hope that the video was helpful, and I apologize for the lengthiness. So good luck.